So here's your 1-6 part 2 homework. Hopefully it's not too bad. Let's see here. I guess I'll do number 3. I have no idea what these are like, but I'll start with number 3. What do I want to attack first? I think I want to go after the x's, because it looks to me like I could just take those two right there and put them together. And if I did, x plus a negative x is nothing. Negative 2y plus 3y is y. 4z plus a negative 2z is a positive 2z. And negative 12 plus 13 is 1. So I'm attacking my x's. Okay. The next thing I'm going to do is I'm going to double this bottom equation, and I'm going to add it to the top because that's going to eliminate the x's again. So if I double the bottom equation, I'll have negative 2x plus 6y minus 4z equals 26. And I'm going to scoot that top equation next to it because I know that if I add those together, that the x's will be eliminated. And that's the goal. It's called the elimination technique. So if you add down, there's no x's, there's 11 y's, there's a negative 7z, and 14 and 26, I feel like that's 40. The only mistakes I really tend to make on these tend to be copy errors. I'm just making sure I doubled things right and copied stuff down right. So let's see here. Do I want to go after the z, which is 7 and a 2? Now the smallest thing they'd enter would be 14. Or do I want to go after the y? I actually want to go after the y's. It's not that hard to multiply this equation by a negative 11. Negative 11y minus 22z is negative 11, and then add down. So if I add down, 40 plus a negative 11 is 29. Negative 7 plus a negative 22 is negative 29. So negative 29z is 29, which means that z is negative 1. Awesome. What do I do with that? Well, I just kind of work my way back up. I plug in. I'm going to throw that guy right there. 11y minus z times a negative 1 is 40. I don't know why I did that. Minus a negative 1. That's a 7. That's what I'm doing. You'll have to forgive me. I am like really off today. It's almost like disorientation. Anyways, there we go. That looks better. Negative 7 times negative 1 is 7. If I and it's positive 7. And if I take that away from both sides, I'd have 33. So my y value is 3. Now I have x and y. Sorry, I have y and z. If I want x, I plug in. So I can put a 3 here, and I can put a negative 1 there, right? So 2x plus 5 times a 3 minus 3 times a negative 1 must be 14. So 2x, here we have 10 plus 3, so plus 13 is 14. Look at that, I got a fraction. 15, no I don't. I'm just being slow. This is 15, this is positive 3. If you put those together, you get 18. There we go. And if we subtract that 18 from both sides, we get negative 4, which means that x is negative 2. So here's our solution. Our x is negative 2, y was 3, and z was negative 1. We have one unique solution. We are consistent, and we are independent. Now let's take a look at what this looks like on Desmos. I'll pause it so I don't waste your time and pull it up. Remember, these are planes. So I've gone to Desmos and I've graphed these 3 planes. And believe it or not, they all happen to intersect in one point. And it's right here, which is where our solution is. That is the one point that those 3 linear planes intersect. So remember, this is about the intersection of planes, and there was one solution, consistent, independent. Okay? Moving forward, let's just look at 5. Why not? What do I want to attack here? X, Y, or Z? Doesn't really matter. I'm going to go after Y this time. So let's see here. Let's double this line. That'll make 10x plus twice y minus 12z is 38. And we'll leave the top line alone. And my idea here was to simply attack y. So add down. There will be 4 x's. There will be no y's. There will be a negative 13z. And that's going to sum to be 21. Alright, so I need another equation that simply has x's and z's, so I have to eliminate y again. Right? What do I want to do this time? I guess this time what I'll do is I'll multiply this one by a negative 3. That'll give me 18x plus 6y plus 3z equals 51. And I'm looking at the bottom equation here. Negative 4x minus 6y minus 6z is negative 20. And then I add down. 18 plus a negative 4 is 14x. There are no y's. 3 plus a negative 6 is a negative 3z. And 51 minus 20 is 31. So let's take a look at my two equations that only have x's and z's in them. I have a 4x minus a 13z being equal to 21. And I have a 14x minus 3z being equal to 31. Okay, so what do you want to attack here? Do you want to attack x or do you want to attack z? I feel like attacking x. Let's see, what's the smallest thing 14 and 4 enter? Probably 28. 4 enters 28 7 times, right? Let's see, let's multiply this one by a negative 2 and then 7 this one. So if I 7 the top equation, I'll have 28x minus 91z's, and that'd be equal to 147. If I negative 2 the bottom one, I'd have negative 28x, and by the way, this is not the only way to do this thing. This is just how I'm choosing to do it, plus a 6z, and that'd be equal to negative 62. So let's add down and see what we got here. 147 minus 62. 7, 15. That's 85 on the right. Negative 91 plus 6 is thankfully now also negative 85. So our negative 85 z's and the x's disappeared. So the z value is negative 1. A dead giver on these things. When people design problems to be done by hand, you expect nice small numbers. So like if you get a nice small number, you can almost do a sigh of relief here. Now what can I do with that? Well, I can feed that in. I'm going to go right there. Okay? I can plug back in. I can use substitution property. 4x minus 13 times that negative 1 is 21. A negative times a negative is positive, so plus 13 is 21. 21 minus 13 is 8. Divide out the 4 and x is 2. So I have x to z. I need y. I plug it in. It doesn't really matter which equation you go after. I'm actually going to go for the second one. It just looks like it's numerically easier for me. 5 times 2 plus the y, which is unknown, minus 6 times that negative 1 must be 19. So this is 10 plus y plus 6 is 19. Now 10 and 6 make 16. 19 minus 16 is 3. So what do we have here? We have a solution at 2, 3, negative 1. Remember the order triple. And it is definitely consistent because it has a solution. Because it has one unique solution, it is independent. I don't know if this homework assignment has anything that's not consistent and independent. It's been 3 or 4 years since I made up this homework assignment, and I don't remember all the answers. All right, write an augmented matrix, do not solve. Do remember you have to be in standard form. So this one is dealing with m's and n's. It would be m plus n equals a constant, okay? So we're going to shift our 7 n's over, and we're going to leave the constant on the right-hand side. Here, the m gets moved over. The n stays, but the 1 shifts over to the right, changes its sign. So the augmented matrix would have 1's for m's, negative 7 and negative 1 respectively for n. The bar or dash, I always did a bar, is the equality symbol, and both the constants for each row are negative 1. Easy peasy lemon squeezy. Right. System of equations. It says clear the decimal fraction on 9. You can clear a decimal fraction just by doubling something, and that does not change equality as long as you double everything. So if I double it, I'd have 1, 2, still a 0. There's a reason I'm mentioning that. Like, I know a couple of you honors kids are like, why does Milbrath do the things he does? Because Milbrath is several steps ahead of you. Like, I'm not thinking about today's lesson. I'm thinking about a lesson a week from now. You don't want fractions in what you're about to do, so clear the fraction. All right. Anyways, I'm supposed to write the system of equations. The first row is x, the first column is x, second column is y, third column is the constant, and none of these have the bars. They should have had the bars, but whatever. So this is x plus twice y is 0. Negative x plus 4y is 2. Ta-da! What's sad is there'll still be some kids that don't understand this lesson. So, use a TI-84 to solve these things, kids. I'm going to do 13. That's the only one I feel like doing. That's it. Maybe I should do 10. I don't know. Yeah, let's do 10 and 13. So, you know, your piece of paper says, hey, dum-dums, remember I told you about this website. I'm going to use this website just to show you it works. All right, we have the square root of 3x minus 9. Open advertisement. Square root symbol you can pull up pretty easy. It's right there. What's the rest of that one look like? And it equals x to the 1/3. So x rooftop 1 over 3. And what else do we have here? Plus 4. You play along in a calculator. Like, don't sit there and not learn how to use your calculator. That is the biggest thing, is kids just sit there and they watch and they don't bother trying it. So come test day, they don't know what to do. Why it took you guys 48 minutes to take a test with 22 questions on it and you didn't finish, I don't know. Speed is a quality. It's a good one too. Anyways, you were taught to do a zoom 6, you know, right there, zoom standard. Now there is a solution on this one, and it's off to the right somewhere, like you don't see it. And I think I was hinting on the sheet that you need to do some window adjustments. So I know there's a solution somewhere off here to the right. I'm going to click window, and I'm just going to say my x max is 50 and see what happens. Which was plenty, okay? Plenty. Second trace 5. Get your cursor close, and it's already pretty close. Press enter once, twice, thrice. There is my solution. I've told you by default we go to the 4th decimal place on things. I don't know if you paid attention to that or not, but that's kind of by default, 10,000ths. And what did I type in? I typed in everything as it was written on this one. I didn't do anything special. The window adjustments were an x max equal to 50. And the solution here to the nearest 10,000, 17.5045. Remember, there's after this 4 is a 6, right? We round it up. Let's see here. Now, this one, you don't have to do anything to the left-hand side. Like it can be entered in your calculator the way it's written. But the right-hand side, you're going to have to use exponential notation. So what's inside the cubic root is a 64x minus 3. And the cubic root is equivalent to the 1/3 power. So that's what I'm going to type into y2. I'm going to type that in. And there are ways to pull up a cubic root on a calculator. Don't do it, because you have to understand exponential notation. You have to understand exponential notation. So I will not show you how to actually type a cubic root into a calculator until probably really close to the EOC, because you have to understand exponential notation. But I know I'm just a stupid math teacher. All right, so that's what I typed in. It was the second equation that I had to modify. Dun, 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 dun. Everything looks right. Zoom 6. There's your V. We should start seeing absolute value, or sorry, the cubic root show up in just a little bit. We have two answers, don't we? We sure do. Second, trace 5. Where is my cursor at? Sometimes you have to press the button until you see it. I'm going to go after the left one first. Enter, enter, enter. There's one of them. I'm going to go after the right one. Oops, I evidently did not hit the right thing. So I can trace 5 because the intersect feature. Get close, enter 3 times. Like, it's so easy. But kids will miss it so bad. Apathy. Cannot overcome it. So here's my two answers. Remember, you're rounding to the 4th decimal place, okay? And if there's a 5 or a 6 or a 7 or 8 or 9 after that 4th decimal, you have to round up. So one of them is negative 2.836 what? 7. That 7 turns that 6 into a 7. The other one, x2, is negative 2.2183. There you go, kids. That was just under half your homework for you. It wasn't too bad. You guys can do the rest of it. Some of you won't. You'll act like you're helpless. And that's what you're doing. You're acting helpless, and you are most definitely not helpless. Being helpless is a choice you make. Don't act helpless because you're not helpless.